Section 6.3 is on multiplying and dividing rational numbers. In this very first lesson exercise, it says show how to compute 5 times an eighth using repeated addition. So I would think of it as 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 equals 1, 2, 3, 4, 5 eighths. All right. So the idea that multiplication is still repeated addition. In example 1, they say, suppose a student does not know the multiplication rule for fractions. Explain how to compute 1/2 times 3/4 using 2 diagrams. So what you can see they're doing is over here, they use 1, 2, 3/4. That was their first diagram. And then they kind of slice that in half here. It's kind of a clever way to show now that it's 1, 2, 3, 4, 5, 6, 7, 8. 8 parts, and 1, 2, 3 of them are shaded. So that answer would be 3/8. That's what they ask us to do in lesson exercise 2. Lesson exercise 2 says, explain how to compute 1/2 times 3/5 using 2 diagrams. So I've cut a couple strips here. Here is my 3/5. 1, 2, 3. Okay. And I'm going to do this on the same diagram. If I then take this whole strip and cut it in half this way, right, and just shade half of what we had before. Now I've got 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3/10. Over here it talks about the definition of multiplying rational numbers. Multiply the numerators, multiply the denominators. Underneath an important paragraph, it says, because the definition is written for fractions, we must rewrite mixed numbers as improper fractions before applying this rule. To understand the rule, look back at figure 6-8, 4/2 times a 3/4. Note that there are 1 times 3 or 3 parts darkened out of an actual 2 times 4 or 8 parts. All right. So here in lesson exercise 4, it says in computing 3/7, sorry about that again, times 10/21, why is one allowed to simplify as follows? So this whole idea of cross-canceling can be puzzling to students. So why can we take a 3 out of here, divide that by 3, and divide this by 3? I think of it as, for the same reason we can, to create common denominators, multiply the top and bottom by 3. I see this as doing this. Divide the top by 3 and the bottom by 3. So as long as you do the same thing to the top of the fraction as you do to the bottom, we're dividing by 1, so we're not changing its value, just how it looks. Over here on page 286, there are a couple of homework lesson exercises that I'm just going to ask you to think through. I want to go over example 3 with you, however. It says a 5th grader has not yet learned the rule for dividing fractions. Explain how to compute 4 divided by 1/2 using a measurement picture. Explain how to compute 4 divided by 1/2 with a common denominator. So here's the first solution. The expression 4 divided by 1/2 mean how many halves does it take to make 4? Take 2 halves. It takes 2 halves to make each whole. So we got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 halves in 4. All right. The second way they do this, it says 4 divided by 1/2 equals 8/2 divided by 1/2. Now, how many halves make up 8 halves? So you would have 4 divided by 1/2 equals 8. All right. Again, a couple of good ways to explain things to students. On the top of page 287, for lesson exercise 7, which is in your homework, it says, a 5th grader has not yet learned the rule for dividing fractions. Explain how to compute 3 divided by 4 using a measurement picture. Explain how to compute 3 divided by 1/4 with a common denominator. So again, I've made a grid here out of my free downloaded graph paper. And I've specifically set it up to show how many quarters are in 1. So here's my 1, 2, 3 whole pieces. Okay. And then again, I'm looking at how many quarters are in there. So again, I've set this up so that here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 quarters in 3. All right. With the common denominator method that they showed us also in example 3, let's see, 3 over 1 divided by 1 over 4. Common denominator, we have to multiply the top and bottom here by 4. So 12/4 divided by 1/4. Again, the idea, how many fourths are in 12/4? It seems logical that there are 12, all right? If we flip over and multiply, okay, again, we've got these 4s that can cancel because we can divide the top and bottom by 4, which causes that to happen. And so we end up with 12 that way as well. All right? Okay. In lesson exercise 8, it says, explain how to compute 3/4 divided by 1/8 using a part of a whole diagram. So that's why I made this thing. Again, if you think of this as one whole thing, you know, we're picturing this as one whole thing, and we shade, again, notice I set it up so that my pieces are divided into 8s. If I shade 3 out of 4 of those, okay, how many 8s is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 24 8s. All right. And 24 8s. I'm sorry, 24 8s.